In this particular video, we're going to have 4 different reviews for each of the 4 unit tests, and they will be timestamped with the description if they do not show up automatically on the play bar. For each of these reviews, it'll be in the ballpark of around 10 to 15 minutes each, meant to be quite literally a review of important concepts and what have you associated with the tests, their structuring, things to keep in mind, most helpful homework problems, and the sort. This is because it is as requested by the students to have a solid, concise 10 to 15 minute review for each of the type you might expect at the end of a final lecture for any given unit. So with that, starting with the Unit 1 test, you're going to have 25 questions, multiple choice each, as follows. So your first 2 problems are going to come from a first pool, and an important note is that all of these pools are not publisher pools. These are ones I make myself, so that way we can ensure that you're not forced to take a test within a 2-hour interval without having any kind of possible test sharing shenanigans going on, whilst also ensuring that everyone gets roughly equivalent tests in difficulty. In any event, problems 1 and 2, you're going to get a scenario, and you're going to identify the scale of measurement. It'll be nominal, ordinal, interval, or ratio. By definition, you have your 4 possibilities. Very easy to see what your 4 answer choices will be. For this one, if the correct answer is nominal, and you put ratio, there wouldn't be any partial credit there. If the correct answer is nominal and you put ordinal, then there would be some partial credit, because although you do not have the scale of measurement correct, you at least quickly identify the data value. For problems 3 and 4, your second pool, you're going to be given a data type and asked to classify it. It can be either categorical or quantitative, and it can be either cross-sectional or time series, hence giving you 4 total combinations, which will be your 4 answer choices. There will be partial credit for these ones as well, so if the correct answer is categorical and cross-sectional, and you put quantitative and cross-sectional, you'd receive half of the credit because you got one of the 2 parts of it correct. For 5 through 8, these will be more computational questions associated with tables where you're going to be computing percentage frequencies, relative frequencies, or cumulative frequencies. Again, all of this is going to consist of applied examples because, as promised in the syllabus and throughout the lectures, we're going to have a heavy focus on the applicability of the materials, so that way you can know that what you're learning has value in the real world. Now, for 9 and 10, these will also be based on the tables from 5 through 8, but you're going to be asked for the medians or the modes of the categorical data. Remember that when you're asked for a categorical median or a categorical mode, you don't necessarily have to have all of the individual data points in order to get the associated categorical median or mode. The most important part is that the data is ordinal. That is, we can order it from highest to lowest or the other way around. So for example, if you're giving a number of stars for a restaurant, the stars just stand in for a word, but unless your goal is to have the worst star rating ever, then you prefer to have 5 stars instead of 2 stars. And so that we can order them from 1 to 5 stars. For 11 through 13, you're going to be given a graphical display and asked to identify what display it is. Yes, there will be a pie chart question. Yes, it is usually the easiest question in the whole course, aside from the literal freebies. However, of the over 2,000 students who have taken this course since my time here, there have been exactly 2 students who got the pie chart question wrong. Please keep them in your thoughts, and please let us all hope that no one here joins that illustrious group, shall we say. But regarding the other 2 bar charts, histograms, and what have you, don't forget for bar charts and histograms, big difference is a categorical or quantitative. 14 through 17, you're going to be given some more displays, and you have to categorize their descriptions. So for example, you may be asked to identify if there is a skew, and if so, how significant. So is it significantly skewed left, or slightly skewed right, or anything of the sort? So if the correct answer is significantly skewed left, and you selected slightly skewed left, you'd receive 2 out of the 4 points, if it's worth 4 points, because you get one of the 2 parts to it correct. Additionally, you might have a skew distribution, and it might ask you to identify the relationship between the average and the median. And similar idea holds with the histograms as well. Problems 18 through 20 are usually not only the most missed questions on the Unit 1 test, but usually regarded as the most difficult questions on the Unit 1 test as well. Maybe you've heard of these questions before from one of your friends who've taken this class before. They are regarded as the most difficult. If you're able to get at least 2 of these 3 correct, then it's extremely likely that you'll end up with at least an A on the test because of how difficult they are. You might say, Professor, why are they difficult? The reason why they're difficult is because you have to do multiple things at once on more difficult concepts. So, for example, you might be given a logic scenario, asked to get the original data values out of it, and then do something with those original data values, where if the first part is messed up, then by definition, the second part is almost certainly messed up as well. Now, something important to note, although 18 through 20 will be based on the same scenario, just because you're not able to get, say, 18 correct, that doesn't mean you're guaranteed to get 19 and 20 wrong as well. I promise there will be a way for 19 and 20 for you to get both of those correct, even if you have no idea what to do on problem 18. For 19 and 20, there will be 2 ways of solving each. There will be the way using the correct numbers from problem 18, and then there will be a conceptual way to solve both without needing to have the individual numbers that you may have found from 18. Best practice for these will be the logic question on the homework set, the Unit 1 practice test, and of course the examples we went over in the lectures. For 21 and 22, these will be conceptual questions about Chebyshev's theorem and the empirical rule, and then 23 and 24 will be the computational questions, particularly associated with the empirical rule itself. It's very important to have the graphical display of the empirical rule for these problems, so that way you'll be able to easily work through them. Usually there's at least one student each semester who will crap their pants over problem 25. It's a freebie. Don't worry about it. Now for some things to keep in mind, this particularly for the earlier questions. If it's asked you for scale of measurement or what data type it is, always start off asking yourself, is this categorical or quantitative? Because in the case of identifying what data type it is, by definition, you get that correct, you're already at least halfway there. So you're either going to get at least half credit or full credit. That's an average of 75%. If you get that part wrong, at most 25. So although, technically speaking, this would be worth about half the points, in practice, on average, it's a bit more. Same holds for getting the scale of measurement. If you correctly identify what data type it is, you're either going to get the half credit for putting, say, interval when the correct answer was ratio, or the full credit, say, for putting ratio. But of course, if this is misidentified, it's guaranteed no points because nominal and ordinal in that particular example would not be worth any points. So again, for these first few questions of the test, first question you should ask yourself, is it categorical or quantitative? With regards to shapes of distributions, suppose we have a distribution that is skewed to the left. If it's skewed to the left, that means we have a peak on the right-hand side, then we have a long tail, or at least some kind of a tail, going off to the left. Remember that the median is the halfway point for our distribution. The median is completely unaffected by outliers. Who cares if the smallest value is made half its original size? The median's not affected, but the mean is. So if you took someone's test score, the lowest test score, and dropped it from a 20 down to a 0, the class average might fall by a little bit, but the class median would not be touched at all. And the reverse would be true if we have a distribution that's skewed to the right. If you have a set of test scores, say for a physics class, where the class average is like a 40, but you have 1 or 2 students who are breaking the curve, getting their 90s or 100, then they're going to significantly bring up the average, but again, they won't touch the median. So if our mean is significantly lower than the median, we have a distribution skewed to the left, and of course, same idea for skewed to the right. By that same token, if our distribution is symmetric, then they should be about the same. Next one is pretty self-explanatory. Now going beyond that to the next one, again, like the example of the stars for the restaurants, if our distribution has the ordinal scale of measurement, then we can find our median and mode categorically speaking. So if you have a table of letter grades, even if you do not know the individual numerical grades themselves, as long as you have all the letter grades, or all the number of people who gave 1 or 2 or 3 or 4 or 5 stars, or anything else of the sort, you can then get the categorical mode or the categorical median. However, suppose I asked you for the numerical mode or the numerical median. You don't know that. You might say, oh, well, why wouldn't I know that? Here's the reason why. Even if half the class gets a B, with only 10% of the class getting a C, what if that 10% of the C all had a 71? And those 50% with the B were all pretty evenly spread out from 81 to 89 in the case of the standard letter grade scale. In that case, the mode would actually be in the C range. And in a similar vein, even if we have 100% of our data values all in the B range, where's the median in the B range? You might say, oh, it's probably 85. What if it's 84? What if it's 86? We don't know that for sure. So ensure that you make a careful distinction between the categorical median and the numerical median, and the same idea for the modal options. And finally, for things to keep in mind, if you don't have the original data values, if you have a histogram to work with, you can get limitations on what your range must be. You can get your maximum possible value of the range and your minimum possible value of the range. The maximum is very intuitive. Get your highest possible value and subtract it from the lowest possible value. For the minimum value, it's a little bit different. Let's suppose we have a letter grade distribution, and we have some number of grades somewhere from 90 to 100. Theoretically, all those grades could be 90s, meaning we would take the lower end of that upper class. But let's go to the other end. Suppose we have two people who are somewhere in the 50s. Well, they could be 51, they could be 59. So we'll take the upper end of the lowest class. We subtract that from the lower end of the highest class. That's how we get the minimum value of the range. This helps you get a good estimate for how wide your distribution really is when you have a limited amount of information. Now, I really, really strongly recommend using the practice test for the Unit 1 practice test as the best preparation for the test itself. I do also understand there are many students who like to use the homework sets to prepare as well. Just please keep in mind there are going to be some homework questions for each unit that are not good preparation for the test, and the reason why is that homeworks do not have the same purpose as tests. The purpose of homeworks is to help you understand more basic concepts and computations associated with materials, whereas the purpose of a test is to assess your understanding of those materials and how deep that understanding is. What this means is some of the homework questions will be good preparation for the tests, but some of them will not be. And so for each of these reviews, I have noted down which homework problems will be better preparation for the associated unit test. In the case of Unit 1, the closest ones will be 2, 3, 4, 6, 10, 12, 13, 16, 17, and 18. Again, I strongly recommend the Unit 1 practice test above all else, but for those of you that like to use homework sets to prepare, these will be better than the other homework set questions for preparations. So now the Unit 2 test review. This will be structured a little bit differently than Unit 1 because it'll be more computationally heavy. You'll have a total of 12 questions, although the last one, like with the first test, is going to be a freebie. Your first thought might be, Professor, only 11 questions? This means if I get one of them wrong, I have to run the table in order to get an A. Or maybe if I get one of them wrong, there's no way for me to get an A. What happens, Professor, if I get problem 6 wrong? Doesn't that mean I get problems 7, 8, and 9 wrong? My promise to you is not necessarily. Each problem will be set up such that even if you run into issues on one particular problem for a scenario, that will not necessarily mean that you're hosed for the entire remainder of that problem scenario. Additionally, partial credit is enabled for nearly every single question, so that way, even if you do not hit the correct answer, so long as you have good work part of the way through, you'd receive partial credit. You might think, Professor, how do I get partial credit? Don't have to send you my work? Well, the way the answers will be set up, if you select an answer where you have, say, the first 3 steps correct, but you just mixed up the last step, that answer from the third step would show up as one of the answer choices. So that way we can know for sure that's where you were with your work to ensure that you receive the partial credit that you have earned. So what this means is even if you mix up a question, that does not mean you're doomed for the rest of the test, and it does not mean you're guaranteed to get no points on it. It's possible for there to be no points on it, but that would mean the whole entire part was screwed up. So getting into the problems themselves, your first problem is going to be a logical deduction problem. You're going to have a table and there will be 8 missing blanks, and you're going to have to use logic to get those 8 blanks as discussed in class. Again, if you've done a Sudoku before, you're going to find this to be an absolute cakewalk. The way it's going to show up on the test is there will literally be blanks on the tables. You can simply click the blank, enter the number, and be good to go. Usually problem 1, around 95 to 97% of the points are earned on that for the average student. For 2 through 5, these will be questions based on the table in problem 1. You might say, Professor, that means if I get problem 1, I'm going to get all these wrong. You screwed me. You terrible, evil liar. I'm not a supervillain, don't worry. For 2 through 5, 2 of your 4 possibilities for those will be based on numbers that were already in the table. The other 2 will be based on ones that you fill in. So I'd say, well, Professor, what happens if I fill them in wrong? What happens for, say, 4 and 5? How do I do those? Well, here's what's going to happen. If the numbers are very messed up, then your answer will not show up as an answer choice. So when you're doing problems 2 through 5, if the answer you get does not match any of the options, that means at least one of the following is true. Option number 1, the table was wrong. Option number 2, the table was right, but the work was not. So double check both if you get an answer that does not show up as an answer choice. Additionally, for 2 through 5, partial credit will be enabled. Your first 2 will be probability questions, particularly conditional probability, and your second 2 will be expected value questions. For 2 through 5, pay very close attention to which row or column of the table it is referencing, because even if all of your work is correct, but you reference the wrong row, then you'd only have partial credit instead of full credit. 6 through 9, for question 6, you're going to have a matching where you have 4 scenarios and your 4 answer choices. Your 4 answer choices will be these 4 distributions: binomial, hypergeometric, Poisson, and uniform. You will be able to pick one distribution for multiple scenarios, although I promise you that will not be the case for the correct answers. Each distribution will correspond to a correct scenario. I suppose if you're completely mixed up between 2, you can always pick one distribution for multiple scenarios to try to guarantee some points. I only recommend doing that if you genuinely have no idea which one the correct answer is for. This also won't be like elementary school, where you have a piece of paper and you start drawing lines all over it to make things match up. For here, you'll be able to directly pick the letter and number for the corresponding scenario or distribution. For 7, 8, and 9, you will have 3 of those scenarios and be asked to do probability computations associated with them. Again, partial credit is enabled for these. Usually the binomial and Poisson questions are the ones where students have the most problems in working them on the test. Usually they have the lowest average scores. So pay particular attention to binomial and Poisson in the lectures to ensure that you're good to go on those. 10 and 11 will also involve the same scenario for 10 and 11, not 6 through 9. You're going to be given a pairing of 2 ZX scores, and then you're going to be asked in problem 10 to get the mean and standard deviation from them. And then for problem 11, you're going to be asked to get a probability associated with at least one of those pairings. Something very, very important to note is that you do not have to get problem 10 correct in order to do problem 11, and the reverse is also true. So although they'll be based on the same scenario, they might as well be 2 completely separate questions. Getting one of them right or wrong has no bearing on your ability to get the other one right or wrong. So for some things to keep in mind for this test, the easiest way to differentiate from the binomial and the hypergeometric distributions is to identify if replacement exists. So let's suppose we have a deck of cards and we take a card out of the deck. Suppose it's the ace of hearts. Then we put it back in and we pick another card. Because we put the ace of hearts back in the deck, we can draw it again. So we literally replace the card back into the deck. On the other hand, suppose you're playing Texas Hold'em poker and you're drawing 2 cards into your hand. You draw your first card, it's an ace. There are only 3 aces left in the deck now. You can't put this ace back in, it's in your hand. So you draw a second card to make your hand. Because there was no replacement, now it's hypergeometric. Something else worth noting is when you're doing these computations, there will be many steps along the way. Don't round anything until the very, very end. And the reason why is that if all of your intermediary numbers are rounded up or down the whole way through, then the rounding errors can begin to compound on each other. If you're using Desmos, you can quite literally copy-paste the number to the next line and be good to go. If you're using your own handheld calculator, you should be able to refer your answer from the previous line. But no matter what, Do not round your answer until the very, very end, so that way you don't run into any rounding errors compounding onto each other. Additionally, the dead giveaway that you have the uniform distribution is if you have some variant of the probabilities all the same chance of occurring. So I can say equal chance of occurring, uniformly distributed, etc. You see any of that, that's your big indication that it is the uniform distribution. When you're dealing with your z-tables, do not forget that these give you the probability of being below some given z-score and not above it. So if it asks you for the probability of being above some z-score, you have to get in the table, find the value, and then subtract that from 1 by using the complement law. If you don't subtract it from 1, you will receive partial credit. However, it is very important that you have the complement law fully understood, because it will not only show up in this unit, but it's going to show up in every single unit from this point onwards. So it's very easy for the complement law to result in quite a few lost points by the end of the semester. So always double check to see which side of your line you are on for the normal distribution, and use the complement law appropriately to see whether or not it applies. For the conditional probability law, you can expand it as much as you want. So for example, we usually have it as, say, P of A given B. So let's give this as a real life example to explain it. What is the probability that somebody has a 6-figure salary given that they're a college graduate? That's a standard way of phrasing it. But we can add more conditions. We are not restricted to just one condition in and of itself. We can say, what is the probability of someone having a 6-figure salary given that they are a college graduate and live in California? And we can add more conditions. So if we added a third condition, we could say, what's the probability that someone has a 6-figure salary given that they are a college graduate, they live in California, and they work for a tech company? They're all going to be computed in the similar way. It's equal to the probability of them having a 6-figure salary and being a college graduate and living in California and working for a tech company, divided by the probability that they're a college graduate, live in California, and work for a tech company. Now, when doing the z distribution probability computations, if it's asking you for the probability of not being in between two values, you still have to get the probability of in between, and then again, complement law at the end. Usually your complement law will occur at the end of the problem, so always double check whether or not the complement law applies. And in these cases, if you have a complement law that is determined by the presence of the word not, I promise you it will be bolded, it will be underlined. And in some cases, if it's even one letter, it'll be highlighted as well. So if you're going through the problems and you see any word that is bolded or underlined, triple check your work, because that is me telling you this one word is going to change your whole answer. And of course, as I mentioned above, for 2 through 5, 10, and 11, an answer for one of those has no bearing on the other. So if you have no idea what to do with problem 3, that has no impact on the credits you'll earn for problems 2, 4, and 5. And then finally, for the homework set, again, I strongly recommend using the Unit 2 practice test more than anything else, but for those of you that like to use the homework set as well, the closest ones, again, Unit 2 practice test will be the closest, but for the Unit 2 homework set itself, if you want to know which one of those are best compared to the others, that'll be 2 through 3 parts C through E, then 5, 7, 9, 10, 11, 13, 14, and 16. Now the Unit 3 test. As a heads up, this is the hardest test in the course. I'm not going to hide it from you. I want you to be aware of it ahead of time. And I'm not saying this because I'm trying to scare the crap out of you or anything like that. It's because I want you to be aware of it ahead of time, so that way you can dedicate extra time towards studying and preparing for this test. This is one of the big reasons why we have the more generous letter grade with the letter grade scale itself. Because since the Unit 3 test is not only the lowest scoring of the 4, it also has the widest variance in scores of the 4, meaning if we curved individual tests, your final grade would have a decent chance of being determined by which section you were enrolled in. And I don't think that's fair to you. So again, just keep in mind, Unit 3 is the hardest of the units, so I strongly recommend dedicating extra time for preparing for it. This will be more structured like Unit 1. 25 questions, multiple choice. Your first two problems are going to come from the first pool. You're going to be given real-world scenarios of things that actually happened, and you're going to be asked to identify what went wrong. Notice here, in the case of problems 1 and 2, these are polling aspects and pitfalls. For problems 3 through 5, you'll be given a scenario of a poll and be asked to identify what sampling method it is. In these cases, there will be no partial credit for problems 1 through 5. And the reason why is that a misinterpretation of a result from a survey or a poll has very serious ramifications. If a poll did not give a result anywhere close to the final outcome, whether that might be for customer satisfaction, an election, or preferences between products, those will have very serious ramifications for the company, the person, etc. And that means you have to go through and identify what caused the poll or survey to be off. And if the wrong lesson is taken from that, then it could be even worse the next time. And if someone is running a polling business and that caused them to be wrong again, they might go out of business. So in these cases, the interpretations are very important. There's no partial credit for problems 1 through 5. However, there will be partial credit for 6, 7, etc. At least for these next ones. 6 and 7, these are going to be questions with the central limit theorem, conceptual questions. It'll kind of be like the 3 statements setup where you have 1, 2, and 3, and you're asked to identify which of those statements are true. It's not going to be like the SAT or the ACT where there's no partial credit at all. If you get 2 and 3 correct, which were hard statements, but you accidentally messed up the easy one, you'll have some partial credit. The partial credit is based on how many of them you got correct and the difficulty of the ones that you got correct or incorrect. So if you got the easy one correct, but then the 2 harder ones incorrect, there wouldn't be partial credit for that. But if you have 2 of the 3 statements correct on true or false, then there would be partial credit on that basis. 6 and 7 tend to be 2 of the most difficult questions on the test, so ensure that you are very familiar with the central limit theorem and how it applies. For 8 through 10, these are going to be concept questions about alpha and the confidence level. So for example, if the confidence level is 99%, what's the value of alpha? Which alpha corresponds to the highest confidence level, and vice versa, etc. And what is the relationship between the 2 of them? For 11 through 13, these will be similar to 6 through 7 in that you'll be asked questions about the t-distribution, which distribution is associated with which standard deviation, being known or unknown, etc. The first half of the test, problems 1 through 13, are going to be heavy on concepts. There won't be that many computations on problems 1 through 13. On the other hand, 14 through 25 are going to be much, much heavier on computations. So there will generally be more partial credit for problems 14 through 25 than 1 through 13. So for 14 and 15, you're going to have scenarios where you have to identify the correct sample size given the desired parameters. And again, the applications of this are very significant. When you're given a set of demands by a boss or a manager or what have you, you're going to be asked to satisfy those demands generally with the least amount of money spent. And so therefore getting the appropriate sample size would very clearly satisfy that objective. So for 14 and 15, one of your computational problems will be identifying the correct sample size for a sample mean, and the other will be for a sample proportion. For the sample proportion one, don't forget, the standard deviation is based on the proportion itself, so even if it's not provided, you can still calculate it very easily. For 16 through 18, no partial credit. These are the only 3 questions in the back half of the test where there's no partial credit at all, because these are interpretations of confidence intervals. If an interval is misinterpreted, that could have very serious ramifications in the real world. They'll all be wrong in their own different ways, so there's no partial credit for 16 through 18. For 19 onwards, partial credit will be enabled for all of them, in many cases at least half credit, many of them a bit more than half credit. 19 through 22, you'll need to get probabilities for being above, below, or in between, some relevant sample means or proportions, and then of course working backwards. So what's the probability of our sample mean being at least $50, for example? For these, it's a matter of taking your sample, converting it with the central limit theorem, and then using your z-tables. Something important to note here, do not forget the square root rule. What this means is we always have to weigh by the square root of our sample size, because if we don't, then we're saying the sample size doesn't matter. And then for 23 through 25, these are going to be questions where you create the confidence interval yourself. You'll have one dealing with a known standard deviation for a sample mean. you'll have one with an unknown standard deviation for sample mean, and then one with a sample proportion where the standard deviation is based on that proportion itself. Again, there'll be partial credit enabled for those. For those who'd like to pace yourself when taking the test for the full 90 minutes, the back half of the test will likely take more time for you than the front half. The concept questions are usually you get it or you don't. Whereas the computational ones, there's a bit wider variety in how much credit a student is able to earn. Now for some things to keep in mind for this, when dealing with your polling questions, always default to your largest sample size unless very convincing evidence is given otherwise. In the case of the test, largest sample size is best. And again, with the central limit theorem, you need to be very familiar with every single aspect of it. So though it might be only 2 questions about it because of the statement form, you're going to be tested on every single aspect of the central limit theorem. So even if you know 5 out of the 6 aspects of it, if you do not understand the 6th and final aspect, that'll result in not getting full credit for those 2 questions, but only instead partial credit. When you're dealing with these alphas and confidence levels, simple rule of thumb to keep in mind, the smaller your alpha, the higher your confidence level, hence the wider your interval has to be, because you have to allow for more possibilities in order to be more confident. And the reverse is true. If we don't need to be as confident, then our interval does not have to be as wide. Therefore, there's a higher probability of being wrong, which corresponds to a higher alpha. When you're dealing with your sample size questions for 14 and 15, always round up. Simple reason why, it doesn't make sense to have 17.41 people. I don't know what 41% of a person is. I don't think any of us want to know what that is. So always round up. Never round to the nearest number. Always round up. So even if your answer is 201.01, round it up to 202. And you also need to know which distribution applies to whether or not you know the standard deviation for the population. If you don't know the standard deviation for the population, then you'll use the t-distribution. And if you do, then you'll use the normal distribution. For this test, you will need to have all 3 sets of tables. If you do not have all 3 sets of tables, you're going to find the back half of the test to be nearly impossible. And even with good luck, you'd be looking at best, a C. So it is really, really important that you have all 3 sets of tables printed out to use for the test, and they do not count against your cheat sheet. So you can have them in addition to the cheat sheet, and you're welcome to write on them to work through the tables as need be for the test. There's nothing wrong with that at all whatsoever, and you will not be accused of cheating if you do that. When you're comparing the t-distribution to normal distribution, because we don't know the standard deviation, we have to allow for more uncertainty. That means we have heavier tails. I mean, what does heavier tails mean, Professor? What is a heavier tail? A heavier tail is a wider and longer tail. Because we have because we have more uncertainty, we don't know how much the data is in the middle, so we need to allow for the possibility that we have a wide distribution. Here's what that means. Because it's wider, in order to get the same confidence level, say some p-value, for some given sample size, the n value, we're going to have a larger t-score compared to the same z-score. Because again, more uncertainty, heavier tails, wider distribution. And therefore, if you incorrectly identify whether or not you know the population standard deviation for a given problem, whole thing's going to be wrong. And that'll be wrong right out of the gate. So ensure that you very carefully identify whether or not you know the standard deviation for a given problem. And that also means do not forget the square root rule. If you're going through these computational questions and you do not divide by the square root of n at some point, whole thing's going to be wrong, and that will not be any partial credit, and the reason why is twofold. Number one, that is a big computational mistake. But there's a second reason why. The second reason is that would be us saying sample size doesn't matter. So then why even have sample sizes of 100 or 1,000? If we don't weigh by our sample size, why not poll one person and go with that? And so for that reason, again, ensure that you are weighing by the square root of your sample size as clearly indicated in the formulas. Finally, for homework questions, again, Unit 3 practice test will be your best preparation, but for the homework questions, that will be best preparation. The best ones here will be problems 3, 5, 6, 7, and then 9 through the end of the homework set. A lot of these are more computational ones, meaning for the concept questions, you're really going to have to rely on the Unit 3 practice test and your understanding of those formulas and definitions. All right, the final test in the course, the Unit 4 test, because again, there's no final exam in Math 2345. There's no point in testing you on something 5 seconds after you were just tested on it to impose extra stress on you. Doesn't make any sense in my view, so we don't do that. For the Unit 4 test, your test is going to be broken up into 3 sections, broadly speaking. It'll be more similar to the Unit 2 test than Units 1 and 3. So your first section of the test will be a hypothesis test. I say, Professor, that means if I get the first part wrong, I'm going to get the whole thing wrong. Again, just like with Unit 2, you will have partial credit enabled throughout nearly the whole test, and just because you have one part of the hypothesis test wrong, that doesn't mean everything else will be marked as incorrect. Here's how problems 1 through 5 will be set up. You'll be given a scenario and asked to do a hypothesis test on it. It'll be a real-world applied example. Your first part will be identifying your 2 hypotheses. Your next part will be identifying your value of alpha. Your third part will be identifying which distribution, the t-distribution or the normal distribution, that you will use. Your fourth part will be your computation of either a test statistic or a p-value, depending on what question you're dealing with. And then your fifth part, problem 5, will be your conclusion. So even if you mix up your value of alpha, you will still be able to get everything else correct if you've done those correctly. And again, partial credit will be enabled. So for example, for the conclusion, if you give the right conclusion but the wrong reason, you receive at least some partial credit for having the correct conclusion, if you will. And likewise, if you give the correct reasoning but then you mix up the conclusion itself, there would be some partial credit there. Your middle portion of the test, problems 6 through 10, will deal with scenarios involving type 1 and 2 errors. So don't forget, these are false positives and false negatives. 2 of them will be just straight up true-false. Is this type 1 or type 2? One of them will be the probability of the error occurring. Remember that in the appropriate case, it'd be equal to alpha. And then you're going to be asked to, for the remaining 2, interpret the type 1 and 2 errors presented earlier in the scenario. Keep in mind that the scenarios can change. Because when dealing with type 1 and 2 errors, we have many possibilities. We have to carefully consider which error that we are considering. So for example, in the criminal justice system, we can have the acquittal of a guilty person, or we can convict an innocent person. Those are 2 different errors, and we have to consider them in their separate contexts. Generally, it's considered worse to convict an innocent person because by definition, the guilty person went free because the innocent person was convicted for it. So again, just keep in mind you will have different scenarios of errors occurring. And so ensure that you're carefully paying attention to which scenario you're dealing with within the problems. And then your remaining problems in the test will be questions for Chapter 13, so linear regressions, correlation coefficients, R-squareds, interpretations of those. For this semester, starting 2025, you will have an Excel screenshot of the work. You won't have to compute linear regression on your own. You'll be given most of the numbers, and you're going to be, by and large, asked to interpret those and consider the possible errors made in using Excel. So, for example, when dealing with correlation coefficients, if you're asked to interpret a correlation coefficient, one of the answers might be R-squared. It might be a correct statement, but it's answering a question that was not asked. To kind of put it in a real-world context, imagine if you're asking somebody a question of, what are you doing this evening? And they say, I woke up this morning. Well, who cares if you woke up this morning? That has nothing to do with what you're doing this evening. Put another way, it's dodging the question. And you've probably seen at some point in real life when someone dodges the question, it's probably because they give an answer to your question that you wouldn't like. In a similar vein here, there will be some statements that are correct but do not address the question being asked. So ensure that the answer you're selecting is not only a correct statement, but is also addressing what is being asked. And then, of course, you'll need to provide an interpretation of the linear regression, and you're going to have to be very careful of the common mistakes made with the 2 associated formulas, which are LinS and Corel in Excel. Same as Google Sheets. Both will be the same. Again, the Chapter 13 lecture video very in-depthly details the common mistakes made in using the correlation function and the linear estimate function. You do not have to be very familiar with Excel programming in order to succeed on these two problems. You will not have to open Excel or Google Sheets for the test itself. And of course, if they are open, then it will be flagged. Now, for some things to keep in mind, if your hypotheses are wrong, then your conclusion will likely be wrong. So if you get your hypotheses flipped, even if all the rest of the work is correct, you might accidentally flip your conclusion. You'd still have a good amount of partial credit because your reasoning would be correct, but just ensure that you correctly identify your hypotheses. Remember, the equal sign is always with the null hypothesis. And when you're working through these hypothesis tests, always identify what distribution will be used and your reasoning for it. Remember, if you do not know the population standard deviation, then you'll use t-distribution, and if you do know the population standard deviation, then you will be able to use the normal distribution. And again, you won't be opening Excel or Google Sheets for Unit 4 test. You'll be given a screenshot of the work. It will also tell you what was input into each cell so you have all the available information. So ensure that you are familiar with the common errors made in using Excel. You might say, Professor, this is no fair. You're trying to trick us. Well, remember, in the real world, if you give your inputs in Excel but you accidentally flip your answers around for interpretation, that can have very serious ramifications. There's a bit of an old saying, the world runs on Excel. So if you're using Excel and you don't know how to correctly interpret your outputs, that can cascade into very significant problems. To keep going, again, be careful with your problem context. You can be asked for multiple different errors in the context of each problem, just as how in the real world you have to consider multiple possibilities for things to go wrong. And so ensure that you're very carefully paying attention to which context is being asked for. And in a similar vein as I had mentioned for the correlation analysis, you can have multiple answers that look correct, but many of them are vacuous statements that don't mean anything to what's being asked. As another example, suppose somebody is being questioned on the stand about their alibi for some kind of a criminal trial, and the lawyer says, where were you at 9 o'clock p.m. on the 23rd? And they say, I was at the gas station at 8:45. Well, even if that's a true statement, they asked about 9 o'clock, not 8:45. So ensure that you carefully pay attention to not just if the statement's correct, but if it answers the question being asked. And then again, as I mentioned earlier, just because you mess up one part for a question, that does not mean everything else is going to be marked as incorrect. Partial credit will be enabled for most questions, and just because one question doesn't go well doesn't mean you're going to be marked wrong for everything else. You'll be able to get the rest of the parts for any given scenario correct, so long as they're not wrong like the other one was. Again, I really strongly recommend using the Unit 4 practice test for preparing for this test. It'll be the best test to prepare for its associated unit test of all of the 4. But if you want to use the homework set as well, 3, 5, 7, 8, and 12 will be the closest. For this Unit 4 test, you will get your results back within 24 hours, and although I do have to wait to post final letter grades to Blackboard for when the last student scheduled takes their test, you will not have the letter grade scale changed on you at the last second. I'm not going to spring some kind of a weird curve on you on the last second either. Everything is as stated in the syllabus, so once you get your Unit 4 test score, you'll have all of your grade reported, and we'll be able to directly compare it to the letter grade scale in order to see what letter grade you end up with. So if your Unit 4 test score comes in at 89, and that puts your final grade in 88.2, that'll be an A, period, end of story. I'm not going to round that down and then call it a B. In a similar vein, we're not going to take other people's numbers and round them in different goofy looking ways either. You'll be able to directly compare your final numerical grade to what is in the syllabus to have a very clear statement of what your final letter grade in the course is. And again, if you're not sure how well you need to do on the Unit 4 test in order to get the letter grade you're looking for, if you go into the FAQs folder, there is a grade calculator in there where you can input the grades that you have. So that way you can get a really good idea for how well you need to do on the Unit 4 test to get the letter grade that you are hoping for. So good luck on the final test in the course, and I guess we'll see what happens, I suppose. Unless you're listening to this 5 months in advance, in which case, come back later. All right. Goodbye.